We're live. Good afternoon, good morning, good evening, wherever you are all reaching us from this afternoon. Welcome again to the SAP International Conference for Utilities. I'm very glad to welcome you to the cloud track. And this afternoon we have FARYS talking about their digital journey towards a smart water platform. Just before we start, a little bit of housekeeping. If anybody does have any questions during this session, please feel free to type those in the chat facility and we will deal with them at the end of the session. The session is being recorded and it will be available to access directly after the session is finished via the event platform. And finally, if we do happen to run over because we've got lots of questions, we have an extra 10 minutes. So we're due to finish at 4 p.m. Central European time. If necessary, we can go on until 10 p.m. So without further ado, I'd like to hand you over to my SAP colleague, Thomas Müller. Thank you, Thomas.
Thank you. Hello and good morning, good day, or good afternoon, depending from where you are joining us. And yeah, welcome to the second part of today's IUC Cloud Track. My name is Thomas Müller. I'm part of the IBU Utilities and I will be your moderator for the two upcoming cloud sessions. We will start now with our first session, which will be about our customer FARYS and how they leveraged SAP Cloud for Energy to build their smart meter, smart water platform of the future. The presentation will be held by Inge Oprel, who is Director ICT at FARYS, and Kevin de Wilde, who is a utility sector expert at Capgemini. If you have any questions, please put them into the chat. We will try to answer them during this session or later. So thanks for being with us. And yeah, with that, over to Inge and Kevin.
Good afternoon, everyone. I want to share with you all the way FARYS and PIPA and the Water Group, three Flemish water companies, decided to collaborate together on implementing the digital water meter to our customers and how we are building today on a smart water platform to support the rollout of digital water meters in Flanders. What is on the agenda of this presentation? First, we will deepen in what we expect this smart water platform to have as functionalities and why we chose the components we did. Then Kevin will take over elaborating on the timing of the project and its architectures and scenarios we are implementing on it. Then later on, benefits and outcomes and future expectations of the smart water platform. And we will finish with a demo of the Cloud for Energy, one of the components of the smart water platform. So the goal of the smart water platform is, first of all, we needed all components to be integrated. That means Cloud for Energy, IoT, S/4HANA. This will go in depth view will Kevin present later on. Important for us that we had one source of truth, that we have a platform where we have all the data accessible for the smart metering. We also need extensive analytics on a huge amount of data. And also important was that the smart water platform could provide in the future of innovative functionalities. And it should be a cloud platform. We also wanted it to be a meter independent platform because we want not to have a vendor lock-in of meter vendors, and we want to be able to integrate with different head-end systems or data as a service providers. Which are the use cases of the smart water platform? And on the left side, you will already see which components of the smart water platform will tackle those use cases. The two most important use cases today are the monitoring and validation of meter readings on their completeness and correctness. And this could be daily or hourly meter readings. And we also want to use those meter reading in all existing backend processes like billing, move-in, and so on. And we need to be able to access these meter readings on the fly when needed in the backend processes. These functionalities are covered in the Cloud for Energy of SAP. But also our smart meterings are sending out events and alerts. And we want to monitor those events and alerts for operational analysis, to handle the issues with the meters, and also to generate automated actions, for example, warn a customer when there's a leakage in his home. We also want to monitor and validate non-energy data streams like temperature, battery lifetime, and quality of the meters. And we need the visualization of all this data for internal departments, the customer's interaction center, the meter operation center, and so on. And important was that there was a maximal flexibility in data sources integration and provisioning. This part is covered by the IoT component in the Smart Water platform. Integration and data provisioning of Smart Water platform, what does that mean? First of all, integration means that we looked for standard integrations with the SAP backend systems, integration of master data, meter readings, event data, and in the future, process data. We wanted to have an integration with the two head-end systems we already have implemented. Is the Hydroco head-end system and Fluvius head-end system. Maybe just Fluvius is the energy provider in Flanders, and we plan to do a mass rollout after approval of the pilot phase of smart water meters through communicating through the electricity meters. So these head-end system, they bring meter readings to us, alerts to us, non-energy data. And in the future, we also want the disconnection or flow reduction process to be handled by those head-end systems. We also needed the integration possibility of industrial IoT sensors directly or through other DAS providers. And we needed integrations with other data sources. For example, our SCADA system, where we have our very big transport meters and production sites, where we also want to see the data in the Smart Water platform for reporting and analysis. Important was also that the platform would make it able for us to provision or expose data through an API layer, through either internal reporting tools, specific meter portals or customer portals, direct B2B system integration, for example, for energy management or for our B2B customers, and also provide the data to our regulator and government so that they can access the reporting they need on the smart metering. So over to you, Kevin.
Yep, thank you, Inge. Good day to everyone from me as well. Very short overview first of the timing of this project. It's very high level, definitely not our detailed planning. So we started with a pilot implementation of Cloud for Energy last year, which went live at the end of the year actually. And this pilot implementation was very much a collaboration with SAP as well as part of a co-innovation initiative of which the water companies are also part. So we are happy to say that we are the first customer worldwide who is live with Cloud for Energy in a close collaboration of SAP. Throughout this year, we will be adding the other head-end systems and implementing full scope of functionality on our smart water platform, which will go live beginning of the last quarter of this year. In parallel, we further detailed the architecture, specifically the IoT part. So the alarms processing and events and monitoring will go live also by the end of this year for all of the head-end systems at once. And then we will start working on the data exposure layer, as Inge just explained, basically an API management layer to be able to externalize all of the data that we have captured. FARYS was very much the pilot of this whole architecture. Now we are also onboarding PIPA and the Water Group, the other two water companies that participate in the smart water platform, and they will gradually start using this landscape as well this year or the beginning of next year. So we have talked already about the smart water platform, which is basically a name that we came up with ourselves to indicate that it's a single platform for smart metering for the three water utilities companies. But as you can see here, there's a lot more behind this platform. There are many different components inside the platform. That's why we opted for a single name for the platform, even though it's composed of multiple SAP components. We'll go through them so that you get an idea of the complexity behind and also the interaction between all of the different components. On the left-hand side of the scheme in red, you have the head-end systems, which are basically outside of our scope. We see those as a data as a service provider, and we simply implement an interface with them to be able to communicate with them in both ways, either sending data, for example, master data to the head-end system, but more importantly, receiving all of the different readings from those head-end systems. In order to simplify the integration, we have a CPI system at the front of our landscape, which is called the Water Integration Layer, or WIL, which basically also simplifies the interaction towards the outside world. So also for these head-end providers, they have a single point of contact, which is the WIL, for all three water companies behind, even though there are three backend systems and there are multiple components in the cloud platform. As far as the head-end providers are concerned, there's only a single interface for them, and that's the WIL. Behind the WIL, we have Cloud for Energy, which stores metering data, of which I will give a demo at the end of this session. And we have the SAP Cloud Platform, now called the BTP platform, where we use the IoT and Predictive Assets Insight components to store all of the other data streams, so the non-energy data flows and the alarms and events, and where we can combine this information also with information of other IoT sensors in the network, which will provide similar information that we can group and combine with each other. We also have an event handling engine within PAI, which can then trigger certain actions towards the backend systems, where it is up to the individual water companies then to decide what exactly they do with these events. So for example, in case of a leakage, we will send the event there is a leakage on the serial number to the water companies, and then each company can integrate this again into their own field service processes, customer communication processes, just the way they like to do it. Because we have different storage locations of the data, we also have a central SAP Analytics Cloud platform where we will recombine the data of different data sources to be able to do joint reporting, not only across the data sources in the smart water platform, but also across the multiple backend systems of the different water companies. This is one of the big advantages of the platform, one of the drivers behind the platform also, that we can combine data of 3 water utilities companies so that we have a bigger volume, we have a broader view on the information, and we can start drawing conclusions across multiple companies, where in the future everyone would be doing the same analysis in their own company. We are now doing one analysis on 3 data sets so that it's implemented only once, and the conclusions can be implemented in the 3 different companies. Technically, of course, we still have another CPI system which does the communication between the on-premise world and the cloud world as well, but that's very much from a pure technical perspective. And then towards the backend systems, 2 companies have an SAP backend system where we use a lot of standard integration functionalities, such as the AMI, Advanced Metering Infrastructure, which has an out-of-the-box interface with Cloud for Energy, and the Asset Central integration, which is the out-of-the-box integration between S/4HANA and the Predictive Asset Insight in the SAP Cloud Platform. So this is a short overview. To some, it might look complex. To others, it might look incredibly simplified. It is indeed a simplified view. If you dig deeper, there are still a lot of technical components behind and a lot more depth in this solution as well. Finally, in order to be able to monitor all of the complex data streams that go through multiple applications, we will be using SAP Process Visibility as a central error overview tool, where we will centralize the errors that occur in the multiple CPIs in the water integration layer, while communicating to the head-end system. So that's from a business perspective, we can follow the end-to-end flow of information through the entire platform. We can monitor the throughput time of this, see if it's in line with the SLAs and the expectations, and whether some flows are stuck in one of the systems. Moving on to some scenarios of how we are using this integration, and I use an even simpler version of the architecture to demonstrate this. People who are familiar with ISU will recognize these scenarios, and mostly they are here just to represent the fact that there is a full seamless integration between your existing processes in your SAP backend system and the new functionality provided by smart meters and the cloud applications of SAP. So our first scenario is a traditional periodic bill that's being created, which is either done on a yearly basis or on a monthly basis, for example. That's a process that starts in your backend system in SAP, as you are used to today, where you select a portion and you launch that portion for meter reading. This will automatically create your meter reading orders. And instead of having an empty meter reading order, now this will automatically trigger an action towards Cloud for Energy, and it will automatically immediately fetch the corresponding meter reading for your requested meter reading date. Cloud for Energy will send the latest available meter reading. So if there's no meter reading for today, but there was one yesterday, then it will fetch the one of yesterday and also adapt the meter reading date in ISU, just like you would do manually, or just like you would do with a process through a website where a customer can enter his meter reading within a time span of a couple of days or weeks. And then it's on to the existing process again in SAP. Nothing changes there. Meter reading goes into billing and your invoice is created in the backend system. Second scenario is much more new. It's the handling of alarms that are either generated by the meter itself, or can be a processed alarm in the IoT platform based on multiple data flows that we combine. So we will either receive an alarm by daily upload or in real time from the head-end system. We will then process this alarm just to make sure that it's a valid one and not, for example, a duplicate alarm that you already received yesterday or the previous hour, just to filter this kind of information. That's also standard functionality in predictive asset insights. And if we determine that it's indeed a valid alarm, we will then send an automatic action to the backend system. And then within that backend system, whatever follow-up action is required by the water utilities can then be started. This can be a workflow in the system. This can be a text message towards your customer that is being created, linked with an interaction record, for example. This can be a work order that is automatically launched for a crew to go on site. These actions are free to define. And then the last scenario is the creation of a new device. Typically, you purchase your devices in your logistics flow. This is an existing process. At a certain moment in time, you will do a goods receipt in your warehouse and you will start the creation process of the ISU equipments. Also, this is an existing process. Only now, because it's a smart meter and you have indicated in the creation that it's a smart meter, the AMI will automatically replicate this master data to Cloud4Energy. And once the device is installed, it will also automatically install and activate the device in Cloud4Energy. This is then also communicated to the head-end system. And as of that moment in time, the head-end system will start sending indexes towards Cloud4Energy, and the device is then fully operational within S4 and ready to use in any business process. Of course, I could draw up a dozen more of these scenarios, but these are just some examples showing basically that most of the stuff is still happening in your S4 system. And the cloud applications are just an extension of your existing processes. They will automate some actions. They will make some new features available, but it's not an entirely different process. I will skip the move out and the disconnection because otherwise it will take us too much time. Inge, back to you for some of the benefits that you have seen of implementing this, and also some future benefits that we anticipate. You're still on mute, Inge.
So one of the major benefits we all have already seen is that we have an IT platform that is completed and is enabling us to roll out the smart water meter at scale. What is also a benefit that it is bringing the Flemish water companies in alignment with their regulator, who has initiatives on managing drought, managing the usage of water. And the platform also will provide a lot of information for analysis, enabling a 360-degree view of activity of our customers and providing valuable insight for the future optimization and, of course, the water usage in Flanders. Concerning the IT part, well, it is a really Cloud4Energy, a software as a service solution, which allows us to implement in a very short time and with a low TCO. And staying within the sub cloud infrastructure means that it's simple to integrate and be compatible with the other SAP systems, whether they are backend system or the IoT platform of SAP as well. Cloud4Energy, as I may say, is very easy to use, and it has a SAP Fiori based tool, which makes it easy for end users to comprehend the functionalities, and training is very limited. It enables us as well to maximize the utilization within the organization of it, because employees from different departments have to have access to the cloud for energy and reporting to do the analytics on the same data. What was the lessons learned? Well, first of all, the Cloud for Energy was in collaboration and co-innovation with SAP, where we saw that the SAP organization had a lot of subject matter expertise on the utilities processes, the IoT technology, and big data. But we really had to align all those expertise because they really are focused on their domain. But we want to go for a full integrated solution, so we need to align all those functionalities in our platform where you can have C4E reporting versus the SAP Analytics Cloud capabilities, for example. But together with SAP, we came to a very good architecture that will fit the needs of FARYS, PIPA, and the Water Group. The co-innovation approach was very much appreciated by business as well, because you work based on use cases. You can clearly state which functionalities you need. And with mock-ups and early development feedback, we had very short loops with business people, so we could avoid misunderstandings on the functionalities being delivered in this co-innovation. For the smart water platform project and architectures, we have to combine a lot of new technologies. We took enough time to think through the entire architecture with SAP and Capgemini. Even though you're only building a small part, we believe that it's very important that you always look at the big picture, so you know that starting small, you will use the right components and the right functionalities of the future platform. Also, a lesson learned is that using an SAP platform for a non-SAP company, I mean, a company that does not have an SAP backend, it clearly shows that SAP has invested a lot of amount of time in the standard integration that does not need to be rebuilt for companies that have a S4 backend system, but it is a huge work to do all these integrations for non-SAP backend systems. So, Kevin, I'm going to.
Yeah. Finally, before we go to a short demo, what do we still have on the lookout for our smart water platform? Because it does not stop with the basic integration flows. Definitely integration of disconnection and flow reduction is an important feature we are looking for in the future. Why in the future? Because simply it's technically not yet possible with our major head-end system. The meters and the head-end system does not support it. But that's definitely an important process to add in the future. On top of that, the further we go and the more data we have in our system, we of course want to automate as much as possible and move into the predictive analytics world by applying machine learning and fault pattern discovery on all of the data sets that we have, so to automatically generate the correct alarms based on historical information and patterns in the system. We want to further extend the asset management to a more strategic level for the 3 water companies with criticality analysis, for example, automatic maintenance plans, which is all standard functionality within PAI. And then based on all of the vast information that we will be gathering, more and more reporting requirements and possibilities will come up in the future, going from operational reporting to more strategical reporting, but then of course also geographically enabled reporting, so that we can see how smart meters are performing geographically, if there are issues in certain areas, which then of course links to outage management and the GIS systems as well. And then some specific use cases for water, water balance, for example, which is basically the comparison between production, import, distribution and usage of water, non-revenue water, which is water being consumed without it being invoiced to someone, which might be completely legal. For example, when you flush the system after works, or when the fire department has an intervention system also somewhere, but non-revenue water can also indicate illegal usage of water, for example. And this is usually done by defining district metering areas, which are smaller measured areas in the network. This brings us to the end of our presentation. I see I have 1 minute left officially on the time. I will allow myself maybe 5 minutes to give a short demo of the Cloud for Energy. I will do a live demo, which, as everyone knows, is incredibly brave or incredibly stupid, depending on how you look at it. So this is the Cloud for Energy application. As explained, most of it happens fully automatically within the system. It automatically receives the data from the head-end system, and it automatically sends information to the backend system whenever needed. So the actions within Cloud for Energy focus themselves on error monitoring and solving errors or issues with the devices. So that's why we have a solve issue app here. And when we go into this application, we basically get an overview of all of the issues with devices that occurs at the moment of indigestion of the data. So I'll simply take the first one here. We have the serial number. There was an issue on the 16th of May, and it said that there's a high amount of estimated values on this device. So let's take a look at this device. We here get, for the affected week, we can see the green bars indicated there are real measured consumptions, and we can see on the 16th that there was an estimated consumption. But this is very nice. More at the bottom, we see some master data which comes from SAP, from the S/4HANA system. We can see the device type. We can also see the location where the device is installed, the different registers that are available. All of this information is replicated from the backend system. But what interests me most now is to know whether this is a one-off occurrence on this meter or something more structural. So instead of just looking at this week, I will look at the past month. And there we see that actually this meter communicates fine. Incidentally, there is a missing meter reading, which Cloud for Energy, by the way, nicely estimates himself based on intrapolations. So this for me is a pretty normal meter, and we don't need to take any specific actions here. We'll take a different device with maybe a different kind of error. And I had some nice other errors this morning. Let's take this one, for example. You can see the interval length here is 60 minutes, which means this device measures every hour. And the consumption is apparently implausible within some time frame. So again, we go in. We can see the affected day because we have hourly readings. We can go intraday. We see the consumption pattern of this device. I need to move the zoom screen because I can't reach the buttons. If we switch the view here, you can clearly see that this consumption during 1 hour is above the defined thresholds in Cloud for Energy. Which indicates that it's exceptionally high. we may take some action. We might consider this is normal behavior. Again, we can look at the affected week or month, for example, and then we see that this meter actually every day, almost every day, exceeds the fixed threshold of Cloud4Energy. So probably in this case, it's just a meter that indeed consumes a lot of data, and we can basically ignore this error. This is on an individual level. This is very much an operational task for the business to do, to go through the errors on a daily basis and see whether something needs to be done or not. Of course, on a higher level, you're also interested in the performance of your entire set of devices that you have, and that's why we have the operational monitoring here, where you can basically do analysis over a longer period of time. So I'll look, for example, at the data of the entire month of May. Then we see here, and again, the zoom window is really bothering me. Let's pop out this graph, then we have some better view. We can see there are a lot of missing values, more than 1,000 missing values this month. Limited amount of thresholds exceeded, so that's fine. I'm rather interested in seeing this by city, for example, so I can simply add another characteristic here. This graph for me is a bit too hard to read, so I will change it to a bar chart, and now I can easily see these different types of errors and then divide it by city in the system. In this case, for example, I'm only interested in these of Ronse, so I can select this. I close the view, and then at the bottom you see that the data table has been filtered to a limited amount of meters. These are exactly those two of Ronse I selected. And we can click through and actually go to the details and see which ones are affected. And again, we can go into the detailed issue view for these meters and see what is going on there. So this is a very short demo of the functionality of Cloud4Energy. As said, it's mostly a tool to follow up your data and to see how your network is basically performing. And then you can take some higher level actions. Maybe you need to improve coverage in a certain area. Maybe you need to modify the validation rules slightly to improve the quality of what is received and processed within Cloud4Energy. With that, I am at the end of my presentation. We could continue for another half an hour. There's still a lot that we could talk about, but we are at the end of our time slot. So thank you for your attendance. Inge, thank you for your presentation as well. Thomas, do we still have time for one or two questions, or do we need to close the session?
Yeah, I think we have 3 minutes left, and we received 2 questions, so let's try to take one quickly. So we have the question here that yeah, it's regarding the meters. The meters that are connected to the platform, do they have integrated or non-integrated communication modules?
Well, the meters, they have, we have at this moment 2 types of meters. We have the head-end system from Hydroco, which connects through 6HOX communication protocol, and the meters have that connection module integrated in the smart meter. For the other head-end system, where we connect with the electricity, the communication device is also integrated in the meter, but there we connect through the M-bus protocol, which is much more low battery consumption and, well, gives us a better connection with the electricity meter, who is then connected through a narrowband IoT through a telco provider. So.
Okay, great. Thank you. And I think with that, we have also answered the second question, which was around which type of communication is being used. Yeah, we received no further questions, and I think with that we can close the session and switch over to the second session of the cloud track. Thank you very much, Kevin and Inge, for providing the insights into the project you have been running with SAP. Thanks for all the information. Thanks for the demonstration. And everyone else, thank you for joining this session, and enjoy the rest of the day at the International Utilities Conference.
You're welcome.
Thank you.
Bye.
Welcome. Bye.
Bye.
Thank you. Bye-bye.